All right, so welcome to another deep dive. And today we're going to tackle something that I think is particularly relevant. If you're prepping for those, those tough senior software engineering interviews, you know how to deal with complexity in system design.
Yeah. I mean, that's a big one, right? I mean, when you get to that senior level, they really want to see that you can think about these things.
Exactly. Like, it's not just about making it work. It's about making it understandable.
Right. Maintainable.
Maintainable, all that good stuff. So today we're going to zero in on a specific pattern that I think is super elegant
Okay.
for managing complexity.
Interesting.
And it basically gives you this way to have like a simplified interface
Okay.
to interact with what could be a really complicated subsystem.
Okay. So like a nice little facade to hide all the messy details behind it.
Exactly. A nice facade. So it's not just about making it easier to use in the beginning.
Right.
It's also about like long-term benefits.
Mm.
How do you keep the system adaptable to change?
Right.
How do you minimize those tangled dependencies that can just drive you crazy in development?
Oh, yeah. Yeah. Especially when you're talking about a large system, right?
Yeah.
Like when you have many moving parts and, things are getting updated all the time.
Yeah.
Yeah. You got to manage that complexity.
You got it. So let's get into it. Imagine this. You've got a situation where you've got all these different parts of your application.
Okay.
They need to talk to different components within this big subsystem.
Right.
What are some of the headaches that can cause when you've got this direct interaction?
Well, I mean, right off the bat, you're talking about tight coupling, right? When all these client components, they know too much about all the little details, these subsystem components.
Yeah.
It gets very intertwined. And so then those subsystem components have to change, as they often do, as requirements evolve.
Of course.
Then you end up having to change all these client components.
Right. It just ripples through the system.
Exactly. It becomes very brittle.
Yeah, it's like one little change over here and suddenly everything over there breaks.
Yeah.
Yeah, that's a nightmare.
And it's harder to understand, too.
Right.
Like, imagine you have a new team member, or even yourself, going back to code you wrote a while ago.
Yeah.
If it's all these direct interactions, it's just so much harder to wrap your head around.
Yeah, it's like trying to untangle a giant knot.
Exactly.
Yeah. Okay, so what's the strategy to get around this kind of complexity?
So that's where the facade pattern comes in.
Okay.
It's a structural pattern. And what it does is it provides a simplified interface to this complex subsystem.
Okay.
Think of it like, I don't know, the front desk of a big company.
Yeah.
You go to one place for all your needs.
Right?
And they handle all the routing and stuff internally.
I got it. So instead of all these components needing to know exactly who to talk to in the back end,
Yeah.
they just talk to this one facade.
Exactly.
Okay.
Exactly.
Cool.
So like if you were to visualize it, you could have, your without facade scenario.
Yeah.
Lots of boxes representing client components, all with arrows pointing to all these different subsystem boxes.
Oh, so it'd be like this messy web of
Yeah,
connections.
it's tons of coupling, tons of dependencies. And then you've got your with facade scenario.
Yeah.
Same client boxes, but this time all their arrows point to one single facade box.
Okay.
And then that facade has lines going to the different subsystems.
Okay, so it's much more centralized.
Much cleaner, yeah.
Got it.
And that leads to some big advantages.
Okay. What are some of those advantages?
Well, first of all, you've got that simplified interface.
Mm-hmm.
Right? Instead of dealing with all these individual interfaces, you have one higher level abstraction.
Makes sense. Easier to use, less to learn.
Exactly. Much more user-friendly.
Okay.
And then the second thing is reduced coupling.
Okay.
Because now those clients, they're only talking to the facade.
Right.
They don't need to know about the subsystem's internal structure.
Okay.
So you can change things within the subsystem without breaking the client code.
That's huge.
Yeah, that's key for maintainability.
Yeah. So as long as that facade keeps offering the same functionality, the clients don't care what's happening underneath.
Exactly. They're shielded from those details.
That's really powerful.
And then the third big benefit is improved readability and maintainability.
Oh, okay.
So when you have all these interactions going through a single interface,
Yeah.
it's just easier to understand how things work.
Makes sense.
Easier to debug, easier to onboard new team members.
It's like you said, you don't have to untangle that knot.
Yeah, exactly.
Okay. So we've talked about it conceptually.
Mm-hmm.
Can we maybe look at a concrete example
Oh, yeah.
to see how this works in practice?
Absolutely.
Something like, I don't know, like compiling code maybe.
Yeah, that's a good one. Compiling code, that's a complex process with a lot of moving parts.
Right. A lot of different stages involved.
Right. So first you have the scanner that takes the raw source code, breaks it down into tokens,
Okay.
kind of like the basic building blocks of the language. Then you have the parser, which takes those tokens,
Yeah.
analyzes their structure, makes sure they follow the grammar rules, often builds up a symbol table in the process.
Right.
Then you might have a program node builder that takes the parsed structure,
Yeah.
creates something called an abstract syntax tree, or an AST,
An AST, yeah.
which is a hierarchical representation of the code,
Okay.
using different types of nodes like statement node, expression node, variable node.
All right.
And then finally you have the code generation phase, which takes that AST and translates it into executable code
Okay.
for whatever target platform you're aiming for.
Okay, so we're talking about, potentially streams, bytecode streams, different code generators like a stack machine code generator or a RIC code generator.
Depending on what you're compiling to.
So, yeah, I mean, just listening to all those different components, it's clear how complicated compiling can be.
It is a lot of steps. And if you imagine a client application like an IDE trying to interact directly with all those, it would be a nightmare.
It would have to know every little detail of the process, right?
The IDE would need to know how to sequence the operations pass data between components handle potential errors.
Yeah.
It would be very tightly coupled to the compiler.
Yeah, it doesn't sound very flexible.
Not at all.
Okay, so how does a facade help in this compiler subsystem?
So in this case, you could have a compiler class as your facade.
Okay.
And this compiler class would have a single straightforward method.
Okay.
Something like compile, which would take the source code and the desired output path as parameters.
So the IDE would just call this compile method, give it the source code and where it wants the output to go.
Right.
And it wouldn't have to worry about all the other stuff.
Exactly. It wouldn't have to deal with the scanner, the parser, any of that.
Okay, that sounds much cleaner.
Yeah. So when the IDE calls compile, the compiler facade handles everything internally, creates instances of the scanner, the parser, the code generator, feeds the output of each stage to the next one.
Yeah.
Manages any intermediate data structures like the AST, and handles any errors.
So it's basically hiding all that complexity behind this one method call.
Exactly. It's abstracting away all those details about lexical analysis, syntax analysis, code generation.
Yeah, that's really neat.
And because of this decoupling, if you decide to change the compiler later, maybe add a new optimization pass or support a new target architecture, you can do all that without breaking the IDE.
That's huge, yeah.
As long as the facade's interface stays the same.
Right, right. So the IDE doesn't care what's happening behind the scenes, as long as it can still call that compile method.
Exactly.
Okay, so we've got our compiler class, and we've got all our subsystem classes like the scanner, the parser, the code generator.
Right.
How are all these pieces structured together?
So the facade class is the central point. It holds references to the instances of the subsystem classes it needs.
Okay.
This is usually done through composition.
Meaning?
Meaning the facade object actually contains objects of these subsystem types.
Okay, so it's like it's got these little helpers inside of it?
Exactly. So when the IDE calls compile on the facade, the facade uses those references to delegate tasks to the appropriate subsystem classes.
Right.
So it tells the scanner to do its thing, then the parser, and so on.
Okay. And the subsystem classes themselves, they're just focused on their own tasks.
Exactly.
I don't even know that there's a facade involved.
They don't need to know. They just do their job when they're called.
Okay.
And, of course, the IDE only interacts with the facade.
Right.
It doesn't know about these individual classes.
Got it. So the flow is basically the client asks the facade to do something. The facade tells the subsystems to do their parts.
Right.
The subsystems do the work, and then the facade gives a simplified answer back to the client.
Exactly. A nice, clean result.
Okay, cool.
So it's kind of like that conductor of an orchestra we talked about before.
All right.
Directing all the instruments, but the audience doesn't need to know about each individual musician.
They just hear the beautiful music.
Exactly.
Okay, so maybe one more example to really drive this home.
Sure. Yeah. What do you have in mind?
Something a little bit more everyday, maybe.
Okay.
Like dealing with a home theater system.
Yeah, that can definitely get complicated.
Right. All those different devices you have to manage.
You got your TV, your Blu-ray player, your sound system, maybe a projector.
Right.
Even smart lights.
Yeah, and just to watch a movie, you have to do all these steps right.
Yeah. Turn on the TV, select the right input.
Right. Make sure the sound system is on and set to the correct source.
Then you got to turn on the Blu-ray player, find the movie.
It's like a whole routine.
Yeah, it can be quite a lot.
Yeah, so without a facade, you're basically interacting with all those devices individually. You have to know how to control each one of them.
You need to know their power states, their input settings.
Yeah, it's not exactly user-friendly.
Not really.
Okay, so let's bring in our facade.
How about a home theater facade?
Okay.
And this facade has simple methods like watch movie and end movie.
Okay, so you just call watch movie, give it the name of the movie you want to watch.
Exactly.
What is it?
It handles everything. It turns on the TV, sets the input, turns on the sound system.
Gets the Blu-ray player going, starts playing the movie.
All those steps.
And then when you're done, you just call end movie.
And it takes care of turning everything off in the right order.
That's fantastic. So you've gone from this whole complicated setup routine to just 2 simple method calls.
Exactly.
It's like magic.
It's all about simplifying the user experience.
Okay, so just to recap.
Yeah.
The facade pattern, it's all about making things simpler.
Mm-hmm.
It provides a clean interface to a complex subsystem.
Right.
It reduces coupling between clients and the subsystem.
Yeah.
It makes things easier to understand and maintain.
Exactly. And it's important to remember, it's different from the adapter pattern.
Okay, how so?
The adapter pattern is about making incompatible interfaces work together.
Okay.
The facade is about providing a simplified interface to a potentially complex subsystem.
Got it.
So even though you have this facade, clients can still access the subsystem directly if they need to.
Right. It's not like it's completely blocked off.
No. The facade just provides a simpler way to do the most common things.
Okay.
And it's also worth noting that a facade can have its own logic.
Mm-hmm.
It's not just a pass-through.
Right. Like in that home theater example, the facade actually implemented the logic for the startup and shutdown sequence.
Exactly.
Okay.
And you could also have multiple facades for a single subsystem.
Interesting. So you could have different simplified views for different types of clients.
Right.
Okay, that's cool.
And at the end of the day, the facade pattern is all about loose coupling, which is what makes systems more flexible and less prone to breakage.
Exactly.
If we had a bit more time, we could dive into another example, like how a virtual memory framework might use a facade.
Oh, yeah, that would be interesting.
But maybe we'll save that for another deep dive.
All right, so for all of you out there who are getting ready for those senior software engineering interviews, understanding the facade pattern is really valuable.
It shows you can think about system design in a way that prioritizes clarity and maintainability.
Right.
And that you understand how to manage complexity, which is crucial at that senior level.
So as you're preparing for those interviews, think about systems you've encountered that might have benefited from a facade.
Mm-hmm.
Where could a simplified interface have made things easier?
Right. Think about those complex interactions and how you could have streamlined them.
Yeah, being able to explain these kinds of design decisions really shows a deep understanding of software architecture.
Absolutely.
Okay, that's a great takeaway. Really appreciate you taking the time for this deep dive.
It was my pleasure.
Always a pleasure.
Always good to talk about these things.
All right, everyone, until next time.
Happy coding.
Happy coding.